We're now going to look at the last section, 3.4, and we've looked at exponential and logarithmic equations, but we're going to look at them as a whole by using this one-to-one and inverse property. So there are going to be two basic strategies that we're going to use for solving these exponential and log equations. The first one is based on the one-to-one property, which we've seen, and we use this to solve simple exponential and logarithmic equations. The second is based on the inverse property, which we have seen. And so for a greater than 0 and not equal to 1, then the properties we're going to see on the next slide are all true for x and y. So if log base a of x and log base a of y are defined, then we know that x is equal to y. As well as if we have a raised to the x and a raised to, which is equal to a raised to the y, this also lets us know that a is equal to y. Okay, so I guess this is a reminder. We saw this on the last slide that if this is the case, then this is if and only x is equal to y, as well as if this is defined, then x is equal to y. So for our inverse properties, we can use this rule here. If I have a raised to the log base a of x, then this just equals the x value. Okay, so if these a's are the same, then it just equals our x value. Same thing as here. If my base here is equal to this a, then it's just equal to x. So log base a of a to the x also just equals x. And I want to recall a rule that we're going to use very often, which is this rule we have here. Log base a of x is equal to y if and only if we take this base a, raise it to the exponent y, we get this value x. So we can use this property for some of our inverse properties also, if it is written in this form. Keep in mind, this is also true for the natural log, and that would just be the natural log of x equal to y is if and only if we take the base, which in this case is e, raised to the y is equal to x. So we're going to look at some simple equations here. And I'm not going to do these on the board because on a separate board because they're just simple equations that we can use our properties for. So we've seen this one actually before, which is 2 to the x is equal to 32. So we want to rewrite the problem so that we have the same base. And we notice here we can rewrite 32 as 2 to the 5th. And now I can use my one-to-one property to just say that x is equal to 5. For our next example, we see that we have natural log of x minus natural log of 3 is equal to 0. If we add the natural log of 3 to both sides, then we have an equation where again we can use the one-to-one property, which would just tell us that x is equal to 3. For our next problem, we've seen these type problems before too. We can rewrite this as 1 over 3 to the x, which we can rewrite as 3 to the negative x. When I bring it to the numerator, the x on it becomes negative. And then we can rewrite our 9 as 3 squared, as we see here. And then we have our one-to-one property again, which tells us that a negative x will be equal to 2, so therefore x is equal to negative 2. You will want to go through and actually write these problems out on your own to make sure that you are understanding the methods. Our next property, we have an exponential, e to the x is equal to 7. So that we can get it into one of the forms that we know and use the inverse property, we can take the natural log of both sides. If we take the natural log of e to the x, we have seen our inverse property tells us that's just going to equal x. And we can just say x in this side we just bring down. And so therefore x is just equal to the natural log of 7. For all this, again, this test we will not have a calculator, so we'll leave all our answers in the form of the natural log. So we would leave it in this form here. And this is our inverse property. So I'm going to do this one in two different ways. Okay. So we have the natural log of x is equal to -3. Just as we took the natural log of both sides in this problem, we can say e raised to this side here. So e raised to this will be equal to e raised to the -3. In this process is what we call exponentiating. When we exponentiate, we take the base and raise the equation to this base. So we have e raised to the natural log of x and e raised to the -3. And of course, we said that this e and this natural log cancel each other out, and it just gives us x. And so x is equal to e to the -3, which we'll leave in that form. Now, a different way we can do this problem, which is a way that I do all my problems, is to use the rule that we have, natural log of x is equal to y. If we take the base, which is our e, raise it to the y, we just get our x value. So I know here that my base is e, and if I raise it to the exponent -3, it should equal this value here, which is our x. And so we skip this step of it exponentiating and go automatically to here. So again, we take the base e, raise it to the y, and then it should equal our x value. So while your slide has it done in this form here, I'm going to do it in the form that we did before. Notice again, our base is 10 because it's just a common log. Sorry for the redundance. But here, if we look at this next f, I'm going to use the rule that I've used before, which is I'm going to take the base, which is 10 in this case, raise it to the -1st power, which is this y, and it should be equal to x. And of course, we know that we can rewrite that as 1/10. Now we can do exponentiating. Since we know the base is 10, we can say 10 raised to the left side and 10 raised to the right side. And of course, this side will give us x is equal to 10 to the -1, because this side, the base and the logs cancel out. Now for this last one, again, I'm going to use the property that I said we can use over and over again. I'm going to take the base, which is 3. And then raise it to the y power, which should be in this case equal to x. And of course, 3 to the 4 will give us 81. If we use this property here, we raise 3 to each side, and this side would just leave us with x. Either way, we get the same solution. So we're going to use this strategies to actually solve all the examples that we did in one. This strategy here is one, we're going to rewrite the original equation in a form that allows us to use what's called the one-to-one property of exponential and log forms. Or, number two, we can rewrite an exponential equation in log form and apply the inverse property of logarithms. If we have a log equation, we can write it in exponential form and use the inverse properties of logs. So let's look at a couple of examples. So we notice this first one, we have the same base. So what we can do is just use the one-to-one property, which will tell us that -x squared equals -3x minus 4. Next, bringing everything to one side, we can add x squared to both sides, but I'm going to keep it on the left. We'll have x squared minus 3x minus 4 is equal to 0. And then we can solve. And we notice we get x minus 4 and x plus 1. And solving each of these by setting them equal to 0, we get x is equal to 4 and x is equal to -1. We always want to go back and check to make sure that these two solutions are solutions and are not extraneous solutions. But we notice we can raise e to any power, positive, negative, or 0, and we still get a value. So when we have exponential functions, they aren't of as interest to us, and both of our solutions will hold. So now let's looking at this again. We see we use the one-to-one property to get to the -x squared is equal to -3x minus 4. Then we write it in the general form so that we can factor both sides. And once we factor both sides, we get our two solutions. X is equal to -1 and x is equal to 4. Then, of course, we always want to check these into our original. And as we mentioned before, it's an exponential, so any value will hold. Let's look at this problem here. We have this equation, and we want to get it into some kind of standard form so that we can use one of the properties that we have. So to have it in a standard form, we first must, ignore that, let me go back. We want to divide each side by 3 so that I have something in the form of a to the x is equal to y. Doing that, I have my 2 to the x is equal to, when I divide this, I have 14. Okay? And now I have it in the standard form. So it says we can rewrite our exponential as a log so that we can use the one-to-one property. And so what do we do? Since this base here is 2, we can take the log base 2 of both sides. Oh, sorry. And so all we've done here is we've taken the log base 2 of both sides, and we do that because we have a 2 here. And why do we want it to be a 2? Because we know that these cancel out and I'm just left with x on my left side. And then here, I would rewrite this into the change of base form. And so we talked about change of base form in the last section, and I'm going to use the natural log of our 14 divided by a natural log of 2. We can use the log of 14 over the log of 2 also. Again, since you can't use your calculators, you will leave your solution in this form here. Okay? But if we were to use our calculator and check our answers in the back, this will give us approximately 3.807. And so now let's look at this form typed out. Our first step is divide each side by 3, as we've done. Our next step is to take the log base 2 of each side. Doing so, we can use our inverse property that says log base 2 of x is equal to x. Then we use our change of base property, and we get natural log of 14 over natural log of 2. And simplifying, using our calculators, using the change of base form, we'll get the 3.807. And we can check this in the original equation, but again, for our exponential functions, it's not so important to us because we know we can raise an exponential to either value. And so let's look at solving log equations by writing them in exponential form. Okay? So if we have this here, natural log of x is equal to 3. If we exponentiate each side, which is e raised to the natural log of x and e raised to the 3, of course our left side becomes x is equal to 3. Just x, which is equal to e to the 3. And I've mentioned before that this process is called exponentiating. Now, when I have a log problem, and I'm going to do my problems from like this from here on out, from this part here, I'm just going to use the rules that we've said before. I'm going to take my base, and my base in here is e, raised to the exponent, which is 3, and this should equal this value here, which is x. And I get to this form here a lot quicker. So from here on out, I probably would not do the exponentiating when we have an e, but I will use this form here, which says that if I have the natural log, of x is equal to y, it is true that e raised to the y is equal to x. And then this is same thing is true if I have log base a of x is equal to y. This is if and only if a to the y is equal to x. So if I were to solve this particular problem here, what would I do? I would take my base, e, raise it to my power, and this is equal to my x. And then we're done with this. E squared is equal to x. Your text would exponentiate both sides, and the ends still get the same formula. For this next problem, what do we notice here? That we already have it in a form where we can use the one-to-one property. And since we have it in a form to use the one-to-one property, we notice that we can just write 5x minus 1 is equal to x plus 7, and that is because we have the same base. And so 5x minus 1 is equal to x plus 7. Then, of course, x is equal to 2.